Hey guys, so today we're going to be talking about Pytorch tensors, like what they are, how to create and initialize them, and just like why we need them in general, right? Okay, so first of all, what is a Pytorch tensor? Well, what's a tensor in general? Well, a tensor is a multi-dimensional array, and first, why do we need tensors? Like, why do we need these multi-dimensional arrays in deep learning and in Pytorch? Well, we use these tensors to represent data for our model. For example, if you want to pass in an image, if you're applying an algorithm on it, you're not going to just like pass in the image directly, right? Like the model can't understand, see, or analyze the image like we humans can. We need to put it in a format, and represent it differently so that the model can actually understand what the image is. And that form happens to be numbers, right? Like you have different pixels, right? You have a length, you have a width, and you also have like normally like 3 color channels. And not only can you use these tensors to represent that data, but you can also like do computations on it. So when you do these different computations on it to like detect a pattern or whatnot, you're gonna have more than 3 dimensions. You're gonna have like n dimensions depending on the number and the scale of your computations. And so, just for our naming conventions, we'll say that a 1D tensor, and remember, tensor is just a multi-dimensional array, and if it's 1D, then it's just like one item in it with like the single brackets around it. And by the way, we add an extra set of brackets, so it's going to be like a nested array or nested list to denote our different dimensions. So we would call a 1D tensor a vector. We would call a 2D tensor a matrix, if you're familiar with those. So like for example, it would just be like an m by n matrix. And anything that's 3 dimensions or higher, anything that's more than 3 dimensions or 3 dimensions, we would just call like a normal tensor. Okay. And we use these tensors to encode and represent, like I mentioned before, our inputs, our outputs, and also our model parameters. And we'll talk more about this in another video. And another side note, these tensors are also very similar to NumPy ND arrays. And so if you're familiar with NumPy, that's great. These operations that we're going to do and the way we create them and initialize them, they'll feel similar and familiar to you. And if you're not familiar with NumPy, that's also fine. We'll go through the creation and initialization in this video. Okay, cool. So let's first start off by importing Pytorch. Okay, and we use that using the import statement and torch. Okay, and let's also import NumPy just to, like see the similarities like towards the end. Okay, great. Once we have these imported, we can finally get towards creating and initializing tensors. Okay. Okay, great. Okay, so one way we can create a tensor is by manually inputting data. Okay, so let's start off by just creating a list, okay? Just a regular Python list, and let's put in some numbers here, okay? 13, 14, 15, okay? And we have, just to clarify, there are two lists inside this outer list. So 16, 17, and 18, okay? You can use Python data from a list or a tuple to create a tensor. Okay, and this is how you would do it. We would say that x is equal to torch. We're referencing Pytorch here, and it has a function called tensor. And we would plug in our manually inputted data into the function. That's the argument. And when we print out x, we see a tensor, right? I mean, it looks the same when you zoom in. Like this is like the same two lists that you see, but it's actually a tensor. And when we want to print the type of x, we get a tensor. It's a torch.tensor. Okay. Okay, great. And I said that you can also use tuples, right? So let's create a variable called y. Let's say torch.tensor, and you don't need to input like a variable. You can just put the data directly inside the function tensor. And let's just put a tuple in 1, 2, 3, 4, and then another tuple 5, 6, 7, 8. They don't need to just be like 2, right? You can input another tuple if you wanted to. And so 9, 10, 11, and 12. Okay? And if you print y, just like we did with x, and you print the type, if you print y, and if we print the type of x, y, sorry, okay, you need another tensor. You need so these are the brackets, right? You can't have like 3 arguments, which is why you take in just like one argument. We use another set of parentheses to denote that, and you can put the 3 inside. Okay, so see here, this is a 3 by 4 tensor, right? If you wanted to print, you don't need to print it in Jupyter Notebook if it's the last line. But if you do y dot shape, we get the size, which is 3, 4. And we'll talk more about this a little later. Okay. Great. So now that we talked about how to like manually input our own values in, let's talk about another way we can create and initialize tensors. And when I say initialize, we are just putting some placeholder values at the beginning. Like if you just, for example, if you say let's create another variable x. If we say torch dot empty, right, and if we say 2 by 3, and we print out x, we get a tensor of this shape that we specified, 2 by 3. And remember, the rows always go first, and then the columns, or like the number of elements, rather, like that's the number of columns, that always goes second. And so when you print this, you get some random values, right? They're not initialized yet, but this prints out like whatever was in the memory at that time. It doesn't initialize it with any values, and therefore, or like hence the name empty, right? So this is a two-dimensional tensor, or a matrix, if you want to call it, like we discussed a few minutes ago. Okay, great. So you can do that. You can just create it without initializing it. But this does reserve a spot for any values that you want to enter in later. But there's another way, apart from .empty. Let's create a markdown cell and just say .empty. Okay, there's another way, which is, well, let's discuss two ways now. It's called .ones and well, let's start with .zeros and .ones. Okay, so these are what you call factory methods. And factory methods are just methods that allow you to populate and initialize tensors of your desired shape based on an algorithm. And the algorithm that we're discussing here is zeros and ones, which we'll see in just a moment. It populates it with values of zeros and ones. It's a very common value to populate your tensors with. Okay, so these are called factory methods. Okay, and zeros and ones, let's see how we use it. So let's just say that zeros is equal to torch dot zeros of, let's just say like the same size, 2, 3, and let's print out our variable called zeros. Okay. Okay, so we have a 2 by 3 tensor. If you wanted to, you could also 2 by 3 by 3. So then you would have like a 3-dimensional tensor. You can do as many dimensions as you want. Because that's the definition of a tensor, right? And you just see here like an extra nested bracket here, and a closing bracket. Okay, so that's how zeros works. So our tensor just got populated with zeros, and our ones works in a similar manner. Let's say 2 by 4. Okay, and print out ones. And let's just print out ones.shape. And let's print out what's the type of ones. Okay. So this is the tensor. It's a 2 by 4, 2 rows, 4 columns. And this is the size, like we specified here. And the type is a tensor, like we expected. So another common way to populate our tensors with random values, right? Just to keep it fair. So let's talk about random tensors and seeding right now. Okay, random tensors and seeding. Okay, so we have a dot rand, and we also have something called dot manual seed. Okay, and we'll talk about that in just a second. Okay, great. So I'm just gonna write it down, type it, and we'll see how it works in just a second. So torch.manual seed, and you just plug in any value you want, any integer, any positive integer that you want. Like if you want 89, it can be 89. If you want 23 or 823, it doesn't matter. Okay. And if we create like a random tensor, let's just call it R1. Okay, we create a tensor by using torch and then dot rand, like a random tensor using dot rand, and then just like we did before, we can say it's 2, 3. Those are the dimensions. Okay, and you can also say torch manual seed, and let's plug in another number, 23. Okay, R2 is equal to torch.rand. Okay, let's make this 3, 5, or let's just keep it consistent. Okay, 2, 3. Okay, and then torch.manual. You'll see where I'm going with this, don't worry. Okay, 823. R3 is equal to torch.rand, 2, 3. And then let's keep the same number here again. I'm gonna copy paste it. Okay, R4 is equal to torch.rand, 2, 3. And one last one, I'm not gonna use any manual seed. R5 is equal to torch.rand, 2, 3. Okay, and at the bottom, let's print R1. Okay, and just an empty line. Print R2, empty line, print R3, an empty line, print R4, an empty line, and finally print R5. Okay, so what do we see here in the output? So you see here where I entered the same number in manual seed, 823 and 823. So that's R1 and R3. So the first one and the third one, you see the same values in the tensors, right? 0.6295, 0.6295, 0.9213, 0.9213, 0.5329, 0.5699, 0.6401, and 0.0037. Okay, and same with the 23. Okay, the second one and the fourth one, you see 0.4283, 0.2889, and so on. But the last one you see is just whatever. So what manual seed does is that it doesn't guarantee reproducibility, but it's very close, right? Like when you see here in this small tensor, it's basically the same. And it's common to use random values, but sometimes you're gonna, like for example, in machine learning research, right, you're gonna want some reproducibility in your research, and if you do a random number every time, it's gonna be like, it's not gonna be reproducible, and you're gonna have a harder time with your research. So if you want some reproducibility in your results, then you should use torch.manual-c, and you should do it in the line right before you initialize a random tensor. Okay? Okay, cool. And the last thing I want to cover in this video is how to create a tensor. Like, this is the last way I'm going to discuss. There are more. Definitely check the documentation, Pytorch documentation, for more of these factory methods. But the last way I'm going to discuss in this video is like using a NumPy array, right? Like I discussed in the beginning of the video. So from a NumPy array. Okay, and there's another, okay, let's just create a NumPy array. Okay, and the way we do that is np, right? We imported NumPy as np, and so we do np dot array. Okay, and remember here I declared a variable called data. Let's just use that data. Let's just copy it and use that data to create our NumPy array. Okay, so it's similar, like I mentioned. Instead of like torch.tensor data, we're doing np.array data because it's in NumPy ND array. Or array, rather, sorry. Okay, so let's create a tensor, and let's say torch, like we did before. We've got to specify that these functions come from Pytorch. So that's a reason why we use torch dot from NumPy. That's the name of this factory function. And let's plug in our np array that we declared the line before. Okay, and so if you want to print out tensor, we get this. And right before we declare our tensor, if we print out our np array, let's also print out the type, okay? Just to make sure that this is in fact a NumPy array. See? And numpy.nd array. Okay. Cool. And let's just talk about one last thing. It's another thing I wanted to discuss. Just the last quick thing. If we say tensor.dtype, just like we do in NumPy, we're going to get an int 64. And I'll talk about this in my other video as well on tensor operations. But you can change the data type of the value in your tensor. It's usually a float 32, but if you enter it, you see here, so like, well, that's a bad example. Let's do zeros. You see the 0, it's a float. So if you say zeros, print zeros dot dtype, you get float 32. And so you can change it. I'll discuss it in my next video. But I just wanted to let you know that it's there. And also the random values are random values from 0 to 1. And again, in my next video on tensor operations, you can use like your common operations in math to like manipulate the values of these random values in your tensor. Okay, just to recap, we discussed what a tensor was. It's a multi-dimensional array. We discussed some naming conventions. We talked about how we can create and initialize tensors in different ways, including manually inputting our data, and various factory methods. Please look at the documentation for like more factory methods and different ways to create and initialize tensors. But the few ones that I discussed were .empty, .zeros, and .ones. And we also talked about random tensors and seeding and how .manual seed helps you achieve reproducibility in your results, especially in a research setting. And we also talked about how to create NumPy arrays, how to create tensors from a NumPy array. And we also talked about .shape and .dtype. Okay, so that's just a basic introduction to Pytorch tensors. I hope you learned something and got something out of this video. And don't forget to like, comment, and subscribe. Thank you so much.